So, good morning and welcome to today's colloquium organized by the Center for Mind-Brain Sciences, CIMEC. It is my great pleasure and honor to introduce Professor Terrence Deacon. Terrence Deacon is Professor of Biological Anthropology at the Department of Anthropology and Helen Wills Neuroscience Institute at the University of California in Berkeley. Previously, he held professorship positions at the University of Harvard and at Boston University. His research interests span over several interdisciplinary domains, and I think this is particularly interesting for a PhD program and an institute, our institute, that actually has a strong interdisciplinary attitude and involves many competencies in the study of mind and brain. So his research interests span over brain evolution, the neural basis of evolution of language, emergence theory and complex systems, coevolutionary processes and interaction of biology and social transmission, semiotic theory. So you can perfectly see how he is a perfect representative for the spirit that we have here. He's author of many books and many articles. In particular, he's well known for his seminal book, The Symbolic Species, The Coevolution of Language and Brain, in which Professor Deacon blended anthropology, neurobiology, linguistics, philosophy to examine the evolution of language. In 2005, this book was awarded the J.I. Stanley Prize from the School of Advanced Research in the US, which recognizes innovative works that go beyond traditional frontiers and dominant school of thought in anthropology. Currently, his theoretical interests have focused on the problem of explaining emergent phenomena, such as evolution of language and the generation of conscious experience by brains. His most recent book is called Incomplete Nature, How Mind Emerged from Matter. So please join me in welcoming Professor Terrence Deacon today.
Well, this is a singular honor. To speak to such a broad crowd, I've done what I think is an unusual approach here. My approach will be to basically suggest all kinds of approaches that you may not have thought about. And rather than tell you the history of my neuroscience work or philosophical interests or whatever, I thought I would actually talk about what I think are some problems in cognitive science, not because we're doing anything wrong, but because there may be some broader questions that if we simply look outside of the assumptions we've begun with, that will open up a whole set of new questions that I think will be interesting. Hopefully interesting to a diverse crowd as well. This is why I've titled this part of it, Thinking Outside the Robotic Box. Now, on the left here, I have this picture, which is from a recently published Oxford University Press book with the title Exploring Robotic Mind. Now, what's interesting about this is that in some sense, I think that's what we're doing. Largely, it's not that we understand brains very well. We're struggling to understand brains. There still is no real, what I would call, general theory of brain function. We have lots of good functions about neurons and in a sense, ionic channels and things like that. But we have a long ways to go to understand how whole brains put things together. And that's been one of my interests all along. And as a result, we spend a lot of our time analyzing brains from what I think is more like a robotic perspective, sort of an abstract notion of what a brain or a mind is. And today I will probably not get to all three of these topics, but these are each what I would call out-of-the-box ways of looking at the problem. And so what I want to try to do is to challenge you with some novel ways, at a fairly general level, novel ways of thinking about cognitive science. The first one, which is the main listing for this talk, neither nature nor nurture. I should say that I began my studies of information and linguistics at Harvard and MIT, actually taking a couple of courses from Noam Chomsky. Noam Chomsky and I have never agreed about anything as far as I can tell, maybe politics. But in any case, I spent many, many years battling against his view because I felt it was not biologically sufficient to account for how language works. I've since come around to a partial acceptance that still goes very different from his perspective. His perspective, as though you probably all know, is an innatist perspective that argues that the human brain has some sort of innate knowledge of language that we begin with. I've come to the conclusion that he was right that there is a universal grammar, but that he's wrong that it's innate. Nor is it, from my perspective, a culturally acquired feature. I think that, in fact, as the enigmatic title says here, it's neither nature nor nurture. And I want to impress upon you that possibility because we oftentimes think that those are the only possibilities out there. That to understand something like language or cognition, you really only have the natural sciences or the social sciences to look at. And I want to suggest that it's not quite that simple. The basis for all the things I'm going to talk about today is really a distinction between what I call engineering logic and organic logic. And I'm going to argue that we need to begin thinking in organic terms. And we need to at least recognize that our engineering logic that we're so familiar with does lead us astray sometimes. The picture I show you here this is the only person who was awarded a Darwin Award, who survived. Darwin Award is usually associated with people that self-select, eliminate themselves. This man had this wonderful idea of buying lots of helium-filled weather balloons, attaching them to his lawn chair out of Los Angeles. And he thought he would rise above his neighborhood a little and look down on everybody. He actually packed some beer. You can see some beer packed there so he could enjoy himself while he was floating around over his neighborhood. And he decided that he would be able to adjust his height and lower himself down by taking a BB gun with him, that he could shoot and pop some of these balloons. The problem with this plan is that as soon as he cut the connection to the ground, he rose to over 10,000 feet very rapidly and was afraid to use his BB gun. And began to sort of float out over the ocean. He actually floated over Los Angeles airport, LAX, and got into trouble for that reason. He eventually got down and survived this whole process. He's not with us anymore, died some years later of cancer, but it's an interesting story. The reason I propose it is because it really does a very good job of juxtaposing the engineering logic from the biological logic. Because in the engineering logic, you start from parts, and you put them together. You understand how the parts work, and then you put them together, you assemble them, and you then understand how the whole works. You construct things, in a sense, by imposing structure on the parts, and the parts are selected to go together. The critical problem, of course, as this demonstrates unquestionably, is the sort of unpredictable consequences usually result from this kind of thing. And we find this all the time going on in our own use of technology. And his unintended consequences were, of course, obvious. The biological logic is, in some sense, just the reverse. Biological systems almost always begin as already integrated wholes. Parts aren't put together to make an organism. Parts differentiate out of organisms. It's a very different kind of logic. It's not an assembly logic, it's a differentiation logic. And the first example I want to use to talk about this has to do with language. Linguistics has been very, very powerful at producing descriptions of languages. So we can come up with a set of rules that describe quite accurately and make good predictions about language structure. The question is, are those descriptions also good descriptions about the function, about how the brain does it? It's one thing to describe a process that's finished, and you can look at it, and you can look at a bunch of completed sentences. Because now I can analyze the parts. All the parts are there. I can say the parts and see how they go together to make the whole, for example, a sentence. But what if brains don't do it that way? What if brains instead are using not engineering logic, putting things together, but are using a biological logic? Biology produces complexity the other way around. It produces complexity by differentiation. How would that look? And so what I want to do is to begin to talk about this and to suggest why it might tell us something about language, why it may be the wrong thing to do to look to innateness or cultural instruction or cultural acquisition, learning to understand language. So I'm going to call it a semiotic ungrounding process, and you'll see why I call it this in a minute. Another way to think about it is that signs, like in language, words, are ungrounded sign vehicles. They are sign vehicles that don't carry their reference on their sleeves, so to speak. They don't depict anything, they're not correlated directly with anything, and oftentimes it's been described as arbitrary. The key problem has always been how an arbitrary and ungrounded sign vehicle, like words, can nevertheless be used to communicate in a way that preserves reference, that is actually grounded. And this has produced a series of problems. The classic one is called the symbol grounding problem. And I'm going to argue that it's actually a reverse problem. It's been put in reverse, as though you start with a bunch of parts, symbols, and you have to figure out how they go together. What I want to suggest is it actually works the other way around, more like biological systems. So let me start. I'm going to sit down here so I can actually see what I'm talking about. I will try to make these slides available so that if I don't read everything that I've written here, you can read it subsequently. But generative linguistics, which has been the most powerful linguistics technique and developed over now many generations to be quite good at predicting language structure in a variety of ways, makes a bunch of assumptions that I think lead us astray. They're, in effect, like engineering assumptions. It suggests that word reference is a code-like and arbitrary, unstructured and conventional sort of mapping relationship. This dates back, of course, all the way back to Ferdinand de Saussure, who described language as a signifier-signified mapping relationship, arbitrary reference being the key here. And that you have to acquire this culturally. And that leads to a series of problems because languages are structured. So if it's completely arbitrary mapping, like a code, where does the structure come from? And as a result, the obvious way to approach this is to say, if this is arbitrary, then there must be an independent source of structure, grammar and syntax, that has to be imposed upon it from outside. Not surprisingly, then you look to nature, or you look to nurture for that structure. The idea that languages, that sentences are then structured by putting these two things together, by assembling words into sentences, using rules, in effect is the driving force here. And however you've conceived of the concept of rules, and they can be conceived in different ways in different generative approaches. So that systematicity is the result of this. Now, another way to look at this, I'll try to do it pictorially here. One of the assumptions behind it, and I'm going to argue that there is a universal grammar, but I'm going to argue that it's very different than what we think it is. So here's the classic way to sort of depict this. You make the assumption that there's this arbitrary mapping relationship. It's a code relationship. Interestingly enough, when we normally use code, we use it for encryption. Language is, in effect, if this is a view of it, it's an encrypted form of reference. No wonder people are looking for the code-breaking tool that allows us to figure out how it became grounded and referring. But if it's ungrounded, and you notice by observation that all languages are highly structured, that their combinatorial structure is highly restricted, then it's necessarily, this implies that by inference, if there is a universal grammar, if there's widespread commonality about the structure that language exists, that it must come from some independent source. So this is why we look for it independent of the symbols, so to speak. So the standard model is like this. We have a bunch of things in the world, and indications, objects, temporal issues, and so on. relations of things in the world, and we have to impose on it a set of rules to organize it into sentences. That one system is grounded and one system is ungrounded. That the referential relationship, the relationship between words and things, words and actions, is ungrounded. It's arbitrary. And then to, in a sense, maintain reference in a sentence with an ungrounded system, we have to impose this kind of rule system. And what I want to suggest is that there's something wrong with this view. First of all, I think there's a series of errors that are the basic assumptions behind this that I just outlined. First one is that symbolic reference is code-like and arbitrary. The second thing is that symbolic reference is the simplest form of reference. If it's arbitrary, if there's no features about the sign vehicles that carry reference with them, like pictures do, then it looks like they're simplest, and that pictures and pointings and correlations are more complex in some ways. It suggests also that we have to look to nature or nurture or some interaction between them to make it work. And if you have these separate kind of functions, it also suggests that maybe there's modular areas in the brain that do these different functions, that maybe some of them have been evolved to do a specific linguistic function. And of course, this is all driven by the idea that a good analytic system that analyzes sentences and word structures is also a good way to explain how it works in the brain. That's an assumption that we also make, particularly from the linguistics perspective. The point I want to make here has to do with this last issue. That is, an excellent description of something may not be a good account of how it works. Linguistic descriptions, I think, are excellent at describing this phenomenon. They don't necessarily tell you how the brain does it. But any theory about how the brain does it must end up by producing structures like the linguists have shown. So they have to converge at that level of the produced phenomenon. Well, back in 1990, Stephen Harnad, a cognitive scientist, proposed what he called the symbol grounding problem. And the symbol grounding problem has been sort of a common problem in the cognitive sciences. He asked the question, how can the semantic interpretation of a formal symbol system be made intrinsic to that system, rather than just parasitic on the meanings that are in our head? How can the meanings of meaningless symbol tokens, that is, ungrounded things like words, how can they be manipulated simply by their shapes, a sort of computational model, and still be grounded to reference? How can they ground it out? So it's been compared, the Chinese room argument was that John Searle produced as sort of an argument to try to say that there's something wrong with that perspective. The problem that he recognized at the time is that somehow symbol grounding must be attached to the world, linked to the world somehow. But how? I'm going to skip this except to say a few things. That the symbol, the notion of symbol, as I said before, was made arbitrarily too simple. And this set us up. The idea that a symbol is an arbitrarily mapped sign vehicle of some kind, and that that's all you need to know about it, turns out, I think, to be the cause of a lot of these problems. And nevertheless, it's the basis of what we do when we talk about something as a computation. We talk about the syntax of moving sign vehicles around. So part of what I'm going to say is I think the computation model is also getting in our way. I became interested way back in the 1970s in some philosophical works having to do with what's called semiotic theory. I think that, unfortunately, semiotic theory has been peripheralized, used mostly in the arts, has not found its way back into the sciences like it belongs, or I think it belongs. And as a result, our models of computation really are what you might call meaningless models. That is, they're models without meaning. We have to apply the meaning to them. We have to do the interpretation. And what I recognize is that the logic had to be reversed. that we call iconic and indexical forms of reference. Reference by virtue of similarity in form, reference by virtue of correlation, which are naturally grounded forms of reference, are really the basis upon which symbolic reference is built, not the other way around. It's not that symbols are the simplest and we have to add correlation, we have to add iconism in order to make them work. So let me reverse the logic here to talk about what I call the ungrounding problem. How is it that we as a species and we as children learn to use an ungrounded source of sign vehicles to still do grounded communication, reference that's actually linked to the world? So two kinds of grounded communications I just mentioned are iconic, in which we use form to represent pictures, cartoons, but also things like aposematic coloration in the natural world play this role. And of course, most perception is built upon iconism, recognizing similarities of form in some way or another. Also, of course, inferential activity is based upon oftentimes indexical relationships. We call this index finger because when it points to something, there's a correlation in space and time, oftentimes, if not just a correlation in co-occurrence. And so to recognize that a footprint says that somebody was there helps us with that. But also various indicators that we produce are the result of this. We know, for example, the first time we see a windsock, that it's able to indicate the direction and the velocity of the wind, not because we've been told how windsocks work, but because, in fact, we've watched clothes blowing in the breeze. We've watched leaves being fluttered around by the breeze. When we look at this, it's giving us this information because we have prior information. And looking at it, you can see without experiencing the wind, you can infer something that's not there, the wind, by virtue of prior knowledge that you've had. And the question is, how is it that you can go from these grounded forms of reference to an ungrounded form of reference like language? So symbols are ungrounded sign vehicles for obvious reasons. There's nothing about the sign vehicle qualities that necessarily tell you what it's referring to in the world, how it's mapped to the world. So it's obvious that we should call these ungrounded or arbitrary instead. So you can't inspect the sign vehicle and know what it's referring. This is why when we come across runes or ancient writing systems, or even another language that we're not familiar with, as I'm not so familiar with Italian, that it's like it's encoded. It's like it's an encrypted form, and I need the decryption system to figure it out. Here's the problem. The notion of convention that we oftentimes use to talk about this hides another form of communication. Whenever we have to create a convention, an agreement, even if it's not done symbolically, we have to communicate about it because it's about shared information. Communication that allows us to set up conventions like a conventional mapping relationship involves communication. We have to already communicate about it so that symbols don't come into the world automatically mapped, but we can't use just looking at them to do it either. We have to use, the conventions have to be set up by other forms of communication. We have to be using grounded forms of communication, iconic and indexical communication, to construct it. Every child has to do that. So here's the challenge, of course. The words in a language, as this is a depiction of a network of associations from a thesaurus from the word light in English. And you can see that the semantic map that we have in our head must be amazing, astounding. Here, just for one word, just for sort of 2 steps of association away from that, massive connection. So what we have to learn when we learn a language is not just the mapping of these things to something in the world, but the mapping to the sign vehicles to each other, which is an incredible task. It's amazing that children can do this, that we've each done so. And so here's the problem. We've got this sort of map somewhere in our heads that we have built in. It looks on the surface as there can be no reference, that it's completely arbitrary. So it looks like there's a problem. But again, the problem has to be inverted. It's not that we start with symbols and have to ground them. In fact, it's that we start with grounded symbols and have to, grounded sign vehicles, iconic and indexical ways of communication, and have to figure out how to use that to sort of build up a system that's based on ungrounded sign vehicles. Now, why is that a problem? Or why is that an advantage as well? It's because the grounded sign vehicles, because they contain in the sign vehicle structure itself some features of the reference, they're not very flexible. They're very limited. If you can take your sign vehicles and unground them, so to speak, now the combinatorial possibilities become huge. There's a tremendous advantage in doing so, but you've got to somehow preserve the groundedness as you build this system. And that's what I want to talk about here. And so this is why I call it the semiotic ungrounding process. Because what has to happen in building a language is we have to figure out how to maintain grounding of reference with ungrounded sign vehicles. So this is why it's the reverse. I've got some pictures to try to get this idea across, to try to make it more intuitive. So one of the ways we do this, of course, is that we use pointing. And one of the things I'll say in a few minutes is that one of the things that we human beings do that most other species don't do when we're very young is we spend a good year of our life just figuring out indexical relations, how to point and how to converge attention on what we point to and what we interact with. And the nice thing about words is that a single word has a very simple iconism to it. The word boy, boy, boy in English, they all sound relatively similar, even though we might be pointing to different things. So over time, one of the things that happens as you begin to discover the class of things that we associate with this word is that we recognize that the pointings are all the same, and we're good at figuring out pointings by the time we're beginning to use language. We use the iconism among sign vehicles that carry nothing but likeness with respect to each other to figure out what is in common between all these things that are being pointed to. It's this problem that the philosopher Willard Van Orman Quine called the ostension problem, the pointing problem. It looks as though you can't figure out with a single pointing what the meaning of something is. But in fact, we don't do it with a single pointing. We do it with dozens and dozens of events in which we begin to differentiate what the sign vehicles are correlated with. And that may be with different things like eating or fruit here. I've given a bunch of examples. My favorite philosopher, Charles Sanders Peirce, called this process abduction, a third kind of inference, different from deduction and induction. We can come back to talk about it, but it basically is sort of the logic of figuring out analogies and metaphors and agreements and iconism. And so the problem, of course, is that we've got to translate these relationships between things and actions in the world into relationships between sign vehicles. Why? Because the sign vehicles themselves have no structure. So the structure must all be shifted. And the problem I want to talk about is how we go from what amounts to all kinds of grounded relationships down here to shifting those relationships to relationships between sign vehicles. So in other words, the relationships that we see in pointing and likenesses in the world, in interacting with each other in these repeatable ways. The sign vehicles, what we represent with them, are in effect linked to what's being represented. They're part of the world in some sense. And as a result, when we want to shift this relationship to arbitrary sign vehicles, the grounding cannot no longer be embodied in the sign vehicles. The grounding now has to be embodied in the relationships between them. What has to happen somehow in learning a language, what we have to do as very young children, is move these grounded relationships, iconic and indexical relationships, into the relationships between sign vehicles. So in other words, if the sign vehicles don't carry it, the combinatorial constraints have to carry it. So we begin grounded, and we progressively have to shift our grounding not onto the sign vehicles, but now into relations between them, the syntax and the grammar. And that's what I want to talk about next. Early on in my work, I worked with a group of people who were at the time in Atlanta, working with chimpanzees. It began with Dwayne Rumbaugh and eventually with Sue Savage Rumbaugh, his wife at the time, working with chimpanzees, doing one of the early language experiments. The ones that caught my attention in the late 1970s and early 1980s were done not with Kanzi the bonobo or Ban-Venetia, who seem to have become very good at it, but actually with a couple of chimps, Sherman and Austin, chimpanzees, not bonobos, who actually had a great deal of difficulty acquiring symbols. But I argued that they learned this process, that what she showed, without really understanding what she was doing, is she helped them to move from grounded sign relations to ungrounded symbolic relations, even in a very, very simple system. And the simple system can be understood this way. They had basically a keyboard system in which there were geometric images on the keys, and you could press them, and by pressing them, you could get a computer system to work, to do various things. And they had food hoppers and liquid devices to give rewards. Early sign training in chimpanzees was all done by using a kind of operant conditioning, in which you cause the animals to make associations, oftentimes with, for example, ASL signs, American Sign Language, hand signs, but also in the early work with Dwayne Rumbaugh's group, with combinations of this sort. What was being developed were a series of correlations. As I push a particular button for banana, and I get a piece of banana. I push a particular button for juice, and I get some juice. Those were direct one-to-one correlations. They were grounded in that respect. You learn a correlation. Any rat in a Skinner box can use this. Any bird, pigeon pecking at signs can do the same thing. So Sue tried to make it just a little more complicated. She said, okay, I want them to learn to only make certain combinations. So to get a liquid, they have to say something that we would gloss as pour juice or pour milk. And to get food things, you have to say give M&Ms or give bean cakes, something like that. And which each of these was taking on a different function. They had to basically do simple correlations, but now correlations between the sign vehicles, not just between what was going on in the world. A really, really simple syntax, you might say. Well, it turns out that this was not easy to do. And it's not easy to do for a very simple reason. That once you require combinations, you get a combinatorial explosion very quickly. She started by training them on learning a bunch of these simple correlations. And as soon as she tried to put them together, the chimpanzees fell to chance. She simplified it and simplified it and simplified it down so that there were eventually only 6 lexicograms they had to know. One for producing liquids and 2 kinds of liquid foods, and one for producing solids and 2 kinds of solid foods. And they corresponded with the delivery devices and foods. Nevertheless, even with just 6 of these, what they're called lexicograms, the combinatorial possibilities are huge. How are the chimpanzees going to solve this? It turns out it took thousands of trials just to get them to figure out these correlations, even though a particular action and the object, an action and the object were simple. To sort out, to figure it out from scratch without knowing anything to begin with was really difficult. What happened is they slowly began to figure out that relations between sign vehicles, that is, these lexicograms, were limited. Certain lexigram combinations never did anything, but you had to unlearn hundreds of possibilities given the combinatorial explosion. Even with just a few, a lot to be unlearned. Eventually in this process, they learned to exclude a whole bunch of possibilities. Sue didn't actually allow them to progress to the next stage until they had spent a full day of never making an error. Now you might think about this, is to never make an error, they had to hold in their mind hundreds of illegitimate possibilities. And yet, after a day of doing this successfully, they were beginning to do it almost automatically. It wasn't a difficulty for them. What they had learned in effect was that the other combinatorial possibilities, you didn't have to remember what not to do. You only had to remember a couple of things that you needed to do. Once you learned the negational relationships between these, the combinatorial negations and options, the mnemonic problem became simple. The mnemonic problem now could ignore all of these other correlations. They were not as important any longer. And all you had to do was to pay attention to just a few. And it became a simple problem already. Interestingly enough, after doing this, she tested them in a variety of other ways. One was to generalize. Can you generalize from this? One of the problems we know about language is it looks as though once you start language, it's as though you already know a lot of rules. How is it children seem to know a lot of rules? How can they generalize so effectively? In part because it turns out to be a mnemonic simplification, that you can do a lot less cognitive work to get the same thing done. By shifting not to the correlations between things in the world, between sign vehicles and things in the world, but just between the sign vehicles themselves. If you shift your attention that way, it becomes easier and easier. So as a result, she showed that in fact they could learn a set of associations, so she taught them on understanding food items and tool items, and then spontaneously introduce lots of new foods and tools that they had never had words to talk about them with. They automatically succeeded at generalizing to a whole new class of objects. She did so by matching them to pictures. They generalized to novel pictures. And finally, mapping lexicograms to lexicograms, generalizing to novel lexicograms that they had not used before. So what happened is by using this mnemonic trick in which you shift to looking at the combinatorial relationships between the lexicograms and not the correlations to the world, you could actually simplify the task, but now have a task that was generalizable to any set of combinations. Now, each one of these steps took many trials. It's not that you could learn them immediately, but once you learned one step, you could generalize to the whole class. That's what I call the symbol ungrounding problem. They had learned a very simple symbol system. By shifting the focus from the correlations in the simple iconic and indexical realm into this looking at the correlations and the mapping relationships, the exclusion and inclusion relationships between the tokens alone. Shifting attention to this sort of token-token relationship. So the question is, how is it then that we've done this in language? How does it work? Well, let me give you a really trivial example. Think of the word smooth in English, or hard in English. What comes to mind when I produce the word, maybe associations with other things. You know, smooth and rough, smooth and hard, smooth and easy. A specific reference is not clear. It's a class. In a sense, you've identified a node in a network. Here, a node in a network. How does it refer to something in the world? But notice that I can also do this. Smooth. That action immediately binds the word smooth to something in the world. And it does so because this is indexical. Hard, indexical. The nice thing about an index, a pointer, is a pointer can point to another pointer, and therefore transitively point to something else. The correlation in time of the word hard and doing this is a correlation that's indexical, but this is also indexical by itself. One way to ground in a simple non-sentence, but using a symbol, is to bind it to an index. What I want to suggest is one of the simplest ways that language gets grounded is by binding a symbolic component to an indexical component. So we have lots of indexical features in language, like this, that, the, and, all the words that in English play that sort of a role. And of course, we also have all kinds of pragmatic activities, pointing and gesturing or doing what I just did here. The point I want to make is that, in some sense, one of the mysteries about universal grammar is that a sentence always has to have roughly two kinds of operations. It has to have an indexical kind of operation and a symbolic operation. And I want to argue that the indexical operation basically plays the nominal role, the noun-like role. I could have said, the surface of this table is smooth. This accomplished that by virtue of your knowledge of the likeness of smoothness and the indexicality of it. But smooth by itself doesn't do it. What we call predication always involves two components. Even in computer languages, if you think about it, you have a function and then you have things that the function operates on. The thing that the function operates on are typically pointers to memory addresses in a computer. Or in formal logical systems, you have, like a lambda logic system, you have a function and you have operators that you can operate on. Or in language, we call them arguments. But they're playing, in effect, an indexical role. What I want to suggest is that language is necessarily, the reason we find the universality of something like sentence structure around the world is because what's actually happening is we've encoded into the relationship that we have in sentence structure this linkage, a necessary linkage between indexing, pointing to the world, getting outside of language to refer, and this network. Now, if I had said smooth, waited 5 minutes, and done this, there would be no correlation, no reference. Because within language, the indexical function has to also be correlated. This is one of the reasons I'll argue that proximity plays an important role in language, whether it's inflections in proximate to a word, or as in English, a very word order structured language, proximity in space and time have to play a very significant role. And then you have to have special tricks in order to have long distance dependency. I'll talk about that in just a minute here. So what I want to say is that the ungrounding process is a process of transferring the iconic and indexical features into relations among sign vehicles. And those relationships we call grammar and syntax. What that means is that then you may be able to rethink the structure of language, the structure of grammar and syntax in semiotic terms. They're not just rules. They're not just arbitrary rules applied to arbitrary sign vehicles. They're precisely non-arbitrary. They have to be non-arbitrary or reference is lost. So it's a systematic process in which we learn by making this move. So here's my way of thinking about it. At the bottom here at this figure, that we have a series of correlations and likeness relationships, activities in the world, relations, pragmatic relationships, physical relations, property relationships between things in the world. What actually has to happen is, since the sign vehicles themselves can't carry it. All those relationships have to be transferred into the grammar and syntax. Learning grammar and syntax is about preserving reference, not about applying an arbitrary set of rules to a set of ungrounded things. It's about finding the right way to transfer those constraints into the relations. So when I try to come up with universals in language, I recognize it in terms of a hierarchy of constraints. And I want to focus today not on all the possible constraints, because I think there's a huge number of them, and I identify them as semiotic constraints, processing constraints, communication constraints, and sensory motor schema constraints. Different theories of language, theories of grammar, cognitive grammar, and so on, focus on different levels of these constraints. But some of the constraints are just what is necessary to do it with a brain with limited capacities, with limited attentional and mnemonic capacities. Some of it has to do with the fact that we have to negotiate with these things, and so on. But what I'm interested in today are those things that I would say that arise neither from nature nor nurture. Whereas these bottom set from 7 to 12, in a sense, have a nature-nurture correspondence to it. What I want to argue is those that are semiotic arise neither from nature nor nurture, but are the result of the problem of grounding an ungrounded set of sign vehicles. And that problem is more like the problem of mathematics, my analogy would be this way, that we don't invent mathematics. We invent ways to represent it and document it, but we discover the possible operations. What I want to say is that young children actually discover grammar and syntax. They do so by listening to their language, but they do so because there's incredible constraints on the semiotics. And I've listed a series of them here, which I call, the first one I call is not a constraint, but it's an affordance. Because as soon as you have ungrounded your reference, because it contains no clues as to what it refers to, now recursion suddenly becomes possible. Recursion, because it's arbitrary, it's not constraining what it can refer to. It can even refer to a variant of itself again and again. Recursion is possible precisely because you've ungrounded reference. Recursion of pictures is totally limited. Recursion of pointing is totally limited. But recursion of symbols is unlimited. So one of the things that for example, Noam Chomsky thinks had to be discovered evolutionarily, the capacity for recursive processing, I think is a spontaneous automatic gift of using symbolic reference. A series of other features, predication, compositionality. That's what I tried to show you with this example. That is, you need, every time you introduce new symbolic information, it always needs to be coupled indexically with something, or reference fails. This, I think, is one of the reasons why there's clausal movement constraints. We can't just move things out of the clause, oftentimes. In English, it's particularly constrained, whereas in Italian, because some of the indexical grounding is in inflection and in case, you can now move things because you can keep track of the movement because the indexicality moves with the word. If the indexicality is in a separate word, then you have to keep those words together. Clauses have to be linked and have to have very precise boundaries. Adjacency is one of the things that's involved here. A whole set of rules here. I was going to go into talking about these. I'm going to just skip through them in a moment, but there's a whole series of constraints that I think have to be discovered. And as a result of those constraints, because they come from different sources, the range of probable human languages can be very small. Because you have semiotic constraints, but also processing constraints, communication constraints, and phylogenetic constraints, it's going to limit the range of languages that are out there. Only one of them, in a sense, comes for free. But you have to discover it. You have to have a brain that's capable of doing the work of discovering it. So rather than go through each of these, I want to take a quick jump to a couple of other issues. One is what I call the problem of poverty of the stimulus. One of the classic arguments for generative grammar and for an innate universal grammar is that the children just don't get feedback about grammar and syntax. That turns out to be true in a literal sense. That is, they don't get corrected very often for this. So there's in this respect, the two claims that are behind this, that there's a vast underdetermination of the observed types of sentence structures. If you imagine that the combinatorial possibilities are huge, as would be the case if there are no constraints on combinatorial possibilities, if they're as arbitrary as reference is from ungrounded sign vehicles, then you've got this massive universe of possible combinations. How could you possibly constrain it down if you have to learn it when you're not getting any negative feedback? The second assumption is that there's, in effect, not enough time to do it. The children acquire this rapidly. So the implication is that you must come with a crib sheet, some other source of that information, independent of the interaction of communication. But if we begin to think about the problem as one of maintaining reference by shifting grounding into the combinatorial relationships, then in fact you do find that there's a lot of feedback. But the feedback is not about grammar and syntax directly. Because what's being disturbed by not getting the grammar and syntax right is reference. What children get feedback on is the failure to refer, the failure to pick out what they want to get to, what they want. You get not only pragmatic feedback because you don't get the communication to work. You don't get what you want. But you also get corrective feedback. Oh, you want this or you want that? A series of interactions that allow that feedback. But it's precisely missing the combinatorial relationships that provide the indexicality that disturbs reference. So what children are learning about syntax is which referential relationships work and don't work. How it is that the pointings between words, the correlational relationships between phrases and so on, how they work or fail to work. So they get a tremendous amount of feedback, not about grammar and syntax directly, but about reference, about ambiguity or precision of reference. So my hypothesis is that children effectively discover grammar. But in fact, we have some aids to doing this. We human beings begin life learning all about iconic and indexical communication. For the first year of life, you learn what works and doesn't work by indicating. And we come into the world with a ready mode of indicating, reaching, pointing, grasping, and following gaze, all the things that we begin with that other species don't do. So we don't learn rules. These are not rules. These are simply transferring the constraints of referring indexically from things in the world to indexical relationships between the sign vehicles. And therefore, they're not innate. What's happened is you've got a set of rules, a set of constraints. We know what works iconically and what doesn't work iconically, what works indexically, what doesn't work indexically. And we have to learn to transfer it from one word to two-word combinations and then the larger and larger groups. So effectively, children start language learning at a year to a year and a half after they've acquired an intense training in indexical and iconic constraint. And what has to happen is they know how that works. They know what the limits are on indexicality, the correlational limits, the agreement relationships, and so on, the transitivity relationships. These have already been acquired. What has to happen is they have to be, in a sense, transmitted up. So we do have some evolved predispositions. They are not grammar and syntax and knowledge of a set of rules. They're the constraints that we discover by naturally interacting with these. And this is what radically reduces this domain. Radically reduces this domain of what possible languages, what can work and what can't work in this context. Why acquiring syntax and grammar can be quite rapid, quite easy for children. Unfortunately, not easy for chimpanzees, as the experiments have shown. That means that we have to have aids that help us with that transition. Not that we have innate knowledge of grammar and syntax, but we have to have innate biases in our cognition that make it easy for us to see these relationships and to see the translation of them into other realms. So I've taken up all my time talking about this, not getting to the brain, which I was going to go to, but this can come up in a sort of question and answer session. So I wanted to give just one example of, in a sense, getting away from the engineering logic, getting away from the put parts together to make wholes, to the other way around. Seeing how whole systems can differentiate to produce complex systems. I think that this is true also about how cognition works in general. But one of the problems we've had is that we look at things like language from the outside, from an already structured point of view, and try to describe how that structure can be put together, rather than trying to understand how structure can be differentiated from something that already exists. So I'll stop there and thank you very much.
Thank you very much for this very stimulating talk. You take questions?
I absolutely. That's why I stopped.
Okay. So, yes.
Thank you for the talk. Very interesting food for thought. I have a couple of questions. I'll try to keep them down to a very small number. But the first thing I'm curious about is your theory or idea making the prediction that in case of a kid, like a baby, growing up by himself or herself, would end up developing an indexical or referential system on his own or on her own? Because that's so far as, I mean, we don't have much data about it, but we know that it didn't happen. We have cases of savage kids who never develop language. And so if your idea is right, the prediction, at least it seems to me, that is that in that case you would have like an independently developed language. Or do you think that there is a constraint that comes from the pragmatic communicative domain? Yeah,
so my answer to that would be that what we notice in feral children, as we've recorded them over the years, is that the one area that they have a great deal of difficulty with is in grammar and syntax. They can learn simple word mappings pretty well. And the classic recent case is this young girl that was found in Los Angeles, isolated for many, many years. But of course, we have many histories of this. But there's another side to this as well. It also, I think, gives us predictions about autism. Autism is a case in which children tend not to indicate, not to point, not to engage in joint attention. And one of the areas that they have great difficulty with is acquiring language oftentimes. They, in a sense, begin without some of these aids. They have other aids almost certainly so they can do some of the complexity that they exhibit. But in one sense, this also, I think, helps us understand that autism may also involve not learning that sort of social communication that requires good iconism, good indices to get information across, to get reference, so we can have shared reference. I think that it makes it difficult, and it's not the mapping relationship of words to things in the world that's the problem. It's actually how to then construct these more complicated combinatorial systems that makes sort of autistic language learning so difficult. So I think it both are the case, and I think it's also one of the reasons why other species will have difficulty. Interestingly enough, I think that dogs do a better job of this than chimpanzees do. For a variety of reasons, I think one of the reasons is that they are pretty good at indexicality. and interpreting indexicality and directed attention, whereas chimpanzees seem not to be.
Thanks for your talk. A couple of points. I see your argument with respect to mapping between symbols and objects. But then I look at the slide which is up at this moment, and in this slide what I actually see is one word, brain, which actually has an indexical connection with something that you can actually touch, maybe. And I mean, this is probably a big underestimated problem across all of linguistics. But the fact is that in a typical page of text or discourse, most of the words are actually referring to things that are quite abstract, so quite far removed from the specific object. And the real mystery to me is not so much how we develop the meaning for brain across languages, but how we end up with abstract words like those which are remarkably translatable from one language to the other. So that's a word that refers to properties like beautiful, to abstractions over properties like beauty, and now we find those over and over and over. So that seems, if you start from objects, I think that the big challenge is how you get eventually to this set of words. That seems to be a problem. On the syntactic side, I entirely agree with you that you have to exclude all of those cases of universal that come from semiotic or all sort of different factors, including history. The point is that I'm a linguist by training, and I've worked a little bit on language universal, and it seems to me that when it actually comes down to the nitty-gritty detail work or finding correlation across languages, you find such weird, even within the bound of what seems to be totally arbitrary, you do find the strangest correlation. So, you know, you find that there are languages that have verb initial, verb in second position, verb final, but not penultimate verbs. And it's not really clear why that should be and how to derive this. So the problem of the research enterprise you're suggesting is then, you know, the details, is how you get
Absolutely.
the details and the variety of structural system that you actually do see in language without falling in the danger of predicting that there should be only a single language, like the optimal solution to the mapping problem.
Well, part of the reason to describe this as constraint is not like a rule. A constraint is a statistical property. There are very strong statistical properties and weaker statistical properties. And part of the hierarchy I listed, I'll see if I can go back to it here, is that I think these are hierarchical. Those at the bottom, I think, are the least probable, but still probable, and those at the top are almost inevitable. So that I think one of the problems is we think of universals as maybe one class of things. I think it's a set of constraints that are nested within each other. And therefore what that means is that there can be a lot of variety at this end of things, but not a lot of variety at this end of things. There have to be things like predication relationships. They have to be there, or a reference fails. And the few cases where we don't have it, where we get holophrastic kind of communication, usually the indexicality is the salience of a particular context or particular frame that provides the indexicality for us. But as we move down, there's a lot of variety. What I'm suggesting is to move away from the linguistic mapping logic, rule logic, and to begin to think about the semiotic logic behind sentence structure. So one of the things I'm doing with a linguistic colleague is trying to put together a set of semiotic rules, I list only 6 here, that really characterize languages. And so one of the things that you mentioned early on in your question has to do with what are oftentimes called function words. Function words are particularly hard to make sense of because they don't have dictionary definitions. They don't work like the other symbols, but they work syntactically and grammatically. They accomplish relational features. And what we've tried to argue is that, in effect, we can come up with iconic and indexical rules that they're basically providing. And we can use different kinds of function words and function relationships to accomplish these various things. For example, in long distance dependency, one of the things that's possible is that you can break contiguity, take things out of phrases by virtue of having agreement relationships. And the more you have means of indexically marking things like by gender or by other features, it allows you to jump your long distance dependencies. But that's an iconic relationship that aids indexicality. So part of what the challenge that I think is faced here is that to be able to translate what we've been thinking about in terms of rules into a set of constraints, and then understanding the constraints in terms of the semiotic work that they do. Now, I think they're implicit in the rule systems that most grammars suggest. But what I'm interested in doing is to see if we can, in a sense, reconstruct from the bottom up. Because I think in doing so, we begin to talk about something that's more, you might say, more neurologically consistent. Because we're very good, all animals are very good at these iconic and indexical features. Just can't do this last step that we do. So it's not a finished product, it's a suggestion, so to speak.
I am maybe making just a methodological, very subtle point, but I have the feeling that you're using the word indexical in a very free sense or way, by being a linguist by training as well. I've learned that keeping distinct what indexicals do in the realm of deixis and at that more abstract level, so let's say at the logical level, it's kind of important because you take the sentence, every boy thinks he is a good student, or whatever. If I say the same sentence by using explicit deixis, so by pointing, when I'm saying he, all of a sudden I have the same set of symbols, the same syntax, but I don't have the same reading, so I don't have the same semantics. Okay, but that will be a real indexical. But when the same word, so the same arbitrary symbol, is not linked to reality by deixis, that becomes something completely different. So would you call that free or non-deictic pronoun still indexical or not?
So what you've just done is, of course, use the linguistic distinction between deixis and indexicality. What's happened is that deixis is, of course, a form of indexicality within language. And we've then reserved the term index for extralinguistic relations. But they work by virtue of the same logic. They work by correlation. They work by physical contiguity. They have similar functions, so that the broader semiotic distinction would not separate them out, except that one is encoded symbolically and one is not. The problem is that we can use indexicality to do both. And this is why you can exchange, oftentimes, pointing and gesturing for the nominalization in a sentence. One of the last constraints that I list here is quantification. Quantification is really interesting because it's relevant to both symbolic logic and language. One of the things that we can say about what a quantification does is when you use the phrase all boys, for example. All is a quantification move. All is about telling you about what kind of indexicality you would. So if I say some, it's saying I point to some but not the whole set. Everything I could possibly point to. None, I can't point. Quantification is all about the individuation that indices provide. An index, like a pointing finger, is always singular. What we do, therefore, oftentimes in some languages, particularly in pidgins, for example, instead of quantification, you use duplication. Many, many, many in English is another way to do it. For example, you just simply repeats to provide quantification by literally quantifying. But quantification is an operation on indexicality. The things that are quantified are nouns. Whether they're count nouns or non-count nouns, we have to come up with some quantification. In symbolic logic, you also need to quantify your variables for the same reason, because they're pointers. In computer languages, they're pointers. And if you want to have pointing to multiple addresses, you have to have, in a sense, you have to point to all of those addresses in some way or another. So again, it's indexicality, but I mean indexicality in a much broader sense than just like we use it in linguistics.
My problem is not with the terminology used. My problem is it's actually very factual. So you have the same string or the same symbol that actually maps to one specific object in one case and to no exact object in the other. So it is the same thing, phonologically speaking, and it's the same word, but you have a completely different reference in the two different cases.
So if it's that man or that man, that doesn't change much because that is a singular quantification and it's a local singular quantification. But obviously going to something like all or some, you can't successfully do it by pointing, by extralinguistic indexicality. So what we've found out within language, we can, in a sense, again, compress that problem into a single operation. But again, I think it's still indexicality. And so this is why I mean indexicality in a semiotic sense, not in a linguistic sense. Understanding the basic functional rule and the constraints on it.
So in the let's call it classic neurolinguistics. I don't know if you can, but Chomskyan neurolinguistics. What a lot of people are trying to do is to find a part of the brain that do which one do semantics, the one that does syntax, grammars, and so on. Do you think it makes sense to do the same with the semiotic hierarchy that you presented? So that's iconicity take place somewhere, indexicality somewhere else, symbolic maybe in the neocortex just of humans, or does it make sense to try to do the same enterprise?
It's a great question, and what the second part of this unspoken talk was to go into. And the question is that I think one of the things that we have tended to do, because we use this kind of engineering framework to look at the parts, and therefore look for the part of the brain that does the part that we've identified, is just the inverse of what I would suggest is a model for approaching how cognition does the same thing. The way to think about that is that almost all sensory processes are involved in iconic processing, but at very different levels in very different modalities. The nice thing about iconic processing, I said symbolic, I meant iconic. I'm sorry, that iconic processing is what most perceptual systems do. Iconism is a more or less relationship. That is, some things can be more similar simply by ignoring differences. Almost all of our cognition has to have an iconic base. The question is, where's the indexicality? Indexicality is about relations across time, typically, or across different modalities. It's about linking independent icons. So I was very much influenced by Roman Jakobson's early talks in the 1950s about aphasia. He argued that, in fact, we should divide the brain into posterior and anterior in terms of what he called paradigmatic functions in the sensory parts of the brain and syntagmatic functions in the prefrontal and frontal parts of the brain. I think that is, in fact, more like a more likely way to divide things up. It's not a surprise, then, that Broca's aphasia, like disturbances, oftentimes have to do with sequence analyses, with production of sentences that become telegraphic because you can't string things well. And posterior aphasias of various kinds have to do mostly with what amount to semantic category issues and so on, but no problem with sequences. That tells us that, in fact, the brain as a whole is organized to separate out what amount to the iconic and indexical. And in order to bring them together to behave, of course, they have to be integrated all the time. Memory tends to be broken down this way as well. If you think about episodic memories, memories that are produced by association using hippocampal function to do so, there we remember individual events, not because we repeat them over and over again to acquire them, but we remember them by their situation in an association. That's an iconic kind of memory. But to learn a skill, we have to learn we have to use prefrontal systems, frontal systems, motor systems, and basal ganglia and cerebellar systems that are good at producing redundancy by repetition. Instead of using redundancy by association, we use redundancy by repetition, sequencing. So the brain is broken up to do these tasks already. So what I'm suggesting is that we need to look at the whole brain in doing language, not at these little spots that do aspects of language. Yes, in a brain like ours that is so large and differentiated, there will be differentiation of function, but it's going to be broken down in this way. And it's one of the reasons why recently we've begun to recognize that the whole cerebral cortex, almost every region of the cerebral cortex plays some role, particularly in the semantic analysis of language. A recent study I was going to mention, done at Berkeley by some of my colleagues, has shown that in fact almost every part of the cerebral cortex is involved. That shouldn't surprise us. What this tells us also is that this is a brain in which there are no new kinds of parts. All the same homologs are there in chimpanzees. My early work was done in looking in monkeys for novel homologs, non-homologs to human areas. Didn't find them, not even in the connections between these areas. The chimpanzee-like brain, an ape brain, has been recruited to do language in which all of these cortical structures that were evolved to do different kinds of things, iconic and indexical kinds of analyses, and their combinations, have been recruited to do this novel kind of thing. So it's this interesting problem. Yes, we have a bigger brain, it's more differentiated, but we're using these old systems to do this totally novel kind of thing. Again, it suggests that we need to stop looking in the piecemeal way we've been looking at it and begin to try to understand how the system is differentiated.
Thank you. So, thank you very much again.
Thank you.
And thank you for coming.